Okay, so we're going to talk about logarithms, and I've got y equals 3 to the x graphed here because a logarithm is defined by an exponential. So if we want to discuss or understand the logarithmic function y equals log base 3 of x, and sometimes you'll see it without the parentheses, but anyway, we need to understand that this is the inverse of the exponential y equals base 3, 3 to the x. So the base of the logarithm is going to be the base of the exponent. So I can rearrange this logarithm down here as 3 to the y equals x, or if I like, switch sides, x equals 3 to the y. And so understanding the exponential is vital to understanding a logarithm or the same base logarithm. And if you want to then get, say, a table of values so you can graph this logarithm, one way that you can do that, there's kind of two main methods. One is think of it, at least, if not actually write it out this way, as instead of y equals log base 3 of x, x equals 3 to the y, and then do your table of values backwards. So let's see what that would look like, and then I'll go back to that green graph with the exponential. We'll just kind of see how everything seems to be related. So I'm still going to do x, y in that order, but my x I'm going to think of as being 3 to the y power. And so I'm going to fill in, I'm going to pick values for y, which is opposite of how we would normally do this. Normally we would pick for x. So if I pick, say, -2, -1, 0, 1, 2, then my x is going to be, okay, 3 to the -2 would be 1 over 3 squared, or 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. All right, so let's just go ahead and plot these, and then we can kind of see exactly what's going on with our graph over here. Okay, let me zoom this out just a bit and then move some things around. Okay, so 1/9 -2. All right, we're just going to do the best we can with that. 1/9 -2. So it's like right next to the y-axis. And then 1/3 -1, not too much further from the y-axis. So there-ish maybe. 1, 0 would be there. 3, 1. And then 9, oops, 2, is that right? Yeah. Okay, so we've got the same shape as that green exponential graph, but it's been kind of reflected. And remember that when you have an inverse functions where you switch the x and the y, you end up, your graphs of a function and its inverse are reflections diagonally about that y equals x line. So this guy here, y equals log base 3 of x. So if we look at then these two table of values, notice I just have my x column and my y column are switched. And so then if I look over here, here's my y equals 3 to the x, y equals log base 3 to the x. They're reflections of each other diagonally. So each point has a point that's kind of corresponding on the other graph where the x and the y have been reversed, have been switched. Okay, let's see what else. Oh, yeah, so we know exponential functions, domain is all real numbers, and the range is 0 to infinity, and they have a horizontal asymptote at y equals 0. At least when you're talking about just plain old basic exponential function, y equals number to the x power. This is always the case. So here with our basic log graph, things get switched up. So the domain and range are switched. So the domain is 0 to infinity, and the range is -infinity to infinity. And we can confirm that looking at the graph. And instead of a horizontal asymptote, we have a vertical asymptote. The vertical asymptote is x instead of y. X equals 0. Okay, so let's look at something involving a logarithm where we transform it somehow. Maybe we shift it, or we could reflect it. So let's see. Let me switch colors again and do orange, I guess. Okay, how about we look at the function y equals log base 3 of x, and then plus 1 outside the log. So if we're outside the function and we're adding or subtracting something, then we're either shifting up or down. Adding a positive number is, of course, going to shift it up 1. So if we shift up 1, if you think of shifting the vertical asymptote up 1, well, if you shift a vertical line up or down, it's not going to really change it, right? It's still going to be in the same place. So we're still going to have the same vertical asymptote at x equals 0 or the y-axis, but each of these points is going to shift up 1. But we'll see that's not going to change our domain and range. I'll just go ahead and draw the graph, and then we'll do domain and range. Okay, so let me do the easier points first. So instead of 1, 0, we're going to be at 1, 1. And instead of 3, 1, it'll be 3, 2. And instead of 9, 2 will be, 9, 3. So I'm inside my function. That's okay. Okay. So this is our transform graph. And then if I want to do these kind of more difficult fraction points, they're more difficult to plot. So we were at 1/3 -1, so it's going to be 1/3 0. So that's a x-intercept. And then I'll just kind of draw this as best I can. Okay. Kind of like that. So nothing changed in terms of these major characteristics. The x-intercept changed, but that's basically it. And of course the points themselves, but domain is still 0 to infinity. Range is -infinity to infinity. And any log graph that we'll be looking at is probably going to have that range, -infinity to infinity. I'm trying to think of when that doesn't happen, but again, the ones that we're going to be dealing with, that will be the case. Okay, in the risk of having maybe too much going on here, let's just do one more. Let's look at, so maybe I'll make this, how about blue? So let's do where we look at a log graph that's shifted left or right. So how about y equals log base 3 of x plus 1. So having the plus, and let me get rid of this grid, having the plus 1 inside is going to be a left-right. If we're inside the function, we're doing something horizontally. So we're going to shift this left 1. So shift left 1. So each of our x coordinates is going to decrease by 1. We're going to, remember, start back with the purple graph, right? That was our basic log graph. Don't look at the orange one. Okay, and so maybe I'll try and actually just erase that orange one a little bit, at least as much as possible. Let's move this in, make that easier. Okay. It's fine. Okay, I'll just erase all that. Okay, and then No, let's do this one. Let me draw that back in. Okay. Okay. So there's our basic guy. So then if we shift all of these points left 1, maybe I'll start from over here. This point is at 9, so now it's going to shift left to be at 8, 2. And then this point that was at 3, 1 is going to go to 2, 1. And then this point, our x-intercept, is going to shift left to the origin. And this point, remember, this was at 1/3, x equals 1/3, so it's going to be x equals negative 2/3. So subtract 1/3 minus 1, it's going to be like over here-ish, kind of, and still, though, the same y. And so we had a 1/9, x equals 1/9 at negative 2, y equals 2. So if we shift that left 1, it's going to be, I don't know, was that negative 8/9? And so what happens is that our vertical asymptote, if you want to shift things left or right, it's also going to shift in the same way. So it also gets shifted left 1. And so instead of being now the purple graph had a vertical asymptote at x equals 0, so now our blue graph has a vertical asymptote at x equals negative 1, 0 minus 1. And then the domain is also different. So the domain is at negative 1, or parentheses negative 1 to infinity. So notice how it matches the vertical asymptote, and range, though, stays the same, negative infinity to infinity. By the way, you can also figure out your vertical asymptote and that kind of starting point for the range. If you look inside your log, if it's not just a plain old x, then it's not going to be necessarily vertical asymptote is x equals 0, but you can take your stuff inside your log, in this case x plus 1, and set it equal to 0 and solve. And so if I do that, I get x equals negative 1. That's my vertical asymptote. I could also, instead of saying x plus 1 equals 0, I could focus more on the domain and say, oh, this has to be greater than 0. Because in a regular log graph, this guy over here, log base 3 of just plain old x is greater than 0, right? The domain is x is greater than 0. So you just take the stuff inside your log and set it greater than 0, just greater than, not greater than or equal to, just greater than, and you can figure out your domain and then just make it an interval. Okay, so with logarithms, the trickiest thing, in my opinion, is if you have to shift it to the left or the right, because that sort of changes all of these major characteristics. If you're shifting it up or down, it's not going to change the major characteristics like the asymptote, domain, and range. It obviously just shifts it up or down. Okay, so I think this, dang it, goodness, I think this video is long enough, so hopefully that's helpful.